For chapter 13, the only two things that are in chapter 13 as far as problems are the heat problems, heat of fusion, heat of condensation, heat of vaporization, and heat of solidification. And the hydrate problems, calculating how much is water in a hydrate. Chapter 14 is all the crazy stuff. But for chapter 13 problem, the heat problems, you need that chart. There's a table and a chart. The old book was 350 and 351, but I don't remember the new book. Remember we looked it up last time? A couple of people that stayed here later. 373. See, it's a pain for us teachers, too, when they switch editions. Ah, 366 and 367. And I made those, it's a laminated sheet that you'll get when you take the final in the testing center with that same chart and table. It's like purple, I think. Maybe blue. It's blue. Anyway, you need that in order to do these problems. So okay, that's the question we're going to figure out right now. But I'm going to do a quickie version of this on the board so I can draw on it. Is that big enough? Any guesses what BP and MP stand for? If you go below the melting point, what physical state would that be? Frozen. Solid is actually the name of the physical state. For water, what is it called? If you're in between the melting point and boiling point, what physical state is that? Just be called water if it was water. And then above the boiling point? What physical state, though? Thanks. My lines are crooked and it's kind of bothering me. Get over. Okay, if you are going from solid to liquid to gas, from here to here, is called the heat of fusion. And if you're going from liquid to gas, the heat of vaporization. Or you can also go down this. Some people get confused about that. They think you can only go up it. You can go down it. So if we start at gas and we're heading down to solid, from between the gas and liquid state is the heat of condensation, and from the liquid to the solid state is the heat of, thank you, okay. sometimes it gets confusing because we're saying heat, the heat of fusion, heat of condensation. If we're going the heat of solidification, it's like taking the heat out kind of a thing. If that makes sense? Yeah. It's still energy. It takes energy to go from gas to solid. But we always think of heat as being warm. So I think students get confused by that. And also, heat is measured in calories. Lowercase c. So the label for all of these steps is going to be calories. Okay. So that is the table, kind of roughly, that's on page 367 in the textbook. And then you also need the table that's on 366 that has the specific heat numbers of the 3 states of matter and all the heat numbers. The heat of fusion and heat of solidification are the same number. If you look at that chart on 366, heat of fusion and heat of solidification are both what? 80. Because it takes just as much energy, just as many calories to go from an ice to liquid as it does to go from liquid back to ice. Whichever way you go, it's still 80. And then for heat of vaporization, heat of condensation, it takes just as much energy to go from liquid to gas as it does gas to liquid. And that number, according to the 366 page, is what? Then you only need the specific heat numbers off that page when we get to them. Now there's 2 formulas, I guess you could say, for doing the heat problems. If you're going diagonally, so from here to here is diagonal, here to here is diagonal, here to here is diagonal. These are supposed to be straight. That's the part that's bothering me. Horizontal, I should say. So if you're going diagonal, what is happening on the chart to go diagonal? What's going on? What's going up? Temperature is going up. So the diagonal problem has temperature, a change of temperature in it. For all of these, for both of these, whether you're going diagonally or horizontally, you start with the grams that are in the problem. In this case, where we have 50 grams. But because the temperature is changing in the diagonal one, you have to multiply that by the change in temperature, which is a symbol of a delta sign, a triangle, which means the change of, and then T is temperature. So the change of temperature is always going to be a positive number. Whether we're getting warmer in the water or if we're getting colder in the water, it's still going to be a positive number because it's asking how many spots on the thermometer is it moving. It's not asking, what's the final temperature. So if we're going negative, if we're going down here past the melting point, it's not going to be a negative number here because we're counting how many spots on the thermometer is it dropping. And then you have to multiply this by the specific heat number, which is found on 366 under the specific heat number. Depending on where you are on this chart, depends on which specific heat number you're using. So if we're in this solid part, if we're at the diagonal below the melting point, which number are we going to use for the specific heat in this formula? 0.50. If we are in the liquid part diagonal line, what number are we going to use for a specific heat here? 1. And if we're in the gas part diagonal line, 0.48. If you're anywhere horizontal, heat of fusion, heat of solidification, heat of vaporization, heat of condensation, you still do the grams, but you multiply that by the heat number. So if we're going from solid to liquid, you use the heat of fusion number, which would be 80. So you'd use 80 right here. So this would say heat of fusion. Or it could be any of those 4. Make sense so far? All right, let's do this.
Heat or is that specific heat on horizontal?
This is the heat. If you look at that chart, there's specific heat, which gets used here, but then there's heat of fusion, which you would use if you went from here to here, or there's heat of solidification, which you would use if you went from here to here.
Okay.
Make sense?
Yeah, no, I just want to make sure I got the heading right.
Yep.